Orbital data centers are no longer a science fiction idea. Power grids are straining, water is running short, and local communities are pushing back against new AI facilities on the ground. Now a California startup called Sophia Space is proposing a different solution: modular tiles that generate their own power and radiate heat straight into space. No pumps, no cooling towers, no planning battles. In this video, we break down how their tile architecture works, why passive cooling could change the economics of space-based AI, and whether modular systems are the right path to large orbital data centers. Sophia Space, based in Pasadena, California, is building hardware for computing in orbit. At the simplest level, orbital data centers, or ODCs, are platforms that carry high-performance computer chips and run them in space. Interest in ODCs skyrocketed in the beginning of this year after Elon Musk laid out SpaceX's plans for large numbers of AI satellites and talked about using Starship to deploy 1 million tons of mass into orbit each year. Since then, a growing list of companies, both startups and larger players, have entered the race to deploy AI computing into space. Sophia Space is one of them. Their approach relies on a modular tile-based design that they claim scales more cleanly than conventional methods. We'll look at that design in more detail later. The main technical difference they emphasize is passive cooling instead of the more common active cooling systems. First though, let's look at why so many companies are now trying to put AI data centers in space. Why locate AI computing in space? There are two main reasons. The first is a pure scaling problem. The second is more social and political. Let's start with the immediate practical challenge: scaling. To stay competitive, companies need to train ever larger AI models. That takes a huge amount of electricity and an equally huge amount of cooling to stop the chips from overheating. The power demand will put local and eventually national grids under strain at current growth rates. Cooling those chips also consumes vast quantities of water. On top of that, the environmental permits, local opposition, and the long wait for new power grid connections all slow everything down. These constraints limit how big terrestrial data centers can grow and how quickly they can be built. Right now, building data centers on the ground is still cheaper than putting them in space, but that balance is expected to shift. More launch vehicles are coming online, and larger rockets are moving into commercial service over the next few years. That makes lifting heavy payloads into orbit more realistic than it was even 2 or 3 years ago. We've already seen what large-scale satellite deployment looks like. SpaceX has more than 10,000 Starlink satellites operating. OneWeb has completed a deployment of roughly 650 satellites. These constellations show that putting hundreds or thousands of satellites into low Earth orbit is no longer a stretch. It's becoming routine. Now, let's look at the actual benefits of locating AI computers in space. Benefits of orbital data centers. A lot of the most valuable data is already being collected in orbit: Earth observation imagery, communications traffic, surveillance and tracking. Today, most satellites still have to send gigabytes of raw data down to Earth for processing. With AI compute available in space, those same satellites can analyze the data on orbit and only downlink the useful insights, the targets, or the high-value results. Take maritime tracking as an example. Instead of sending thousands of high-resolution images down to the ground so that someone can search for ships, a satellite can pass the images to an orbiting data center and receive the ship coordinates in return. Only those coordinates need to be sent to Earth. That cuts the volume of data dramatically and speeds up the whole tracking and monitoring process. Now, let's look at a more recent problem facing terrestrial data centers: public backlash. The power and cooling requirements of Earth-based data centers has caused considerable backlash by locals. A number of US states are now exploring ways to slow or limit the growth of new facilities. In some cases, freezing approvals or pausing incentives. New York became the first state to impose a formal statewide moratorium on large new data centers in July 2026. A study from Arizona State University found that the waste heat from these facilities can raise temperatures in nearby neighborhoods by as much as 4 degrees Fahrenheit, roughly 2 degrees Celsius. With demand for AI compute still rising fast, many people argue that a different approach is needed. One proposed solution is to move at least some of that compute into space. In orbit, there are no local residents to object, no planning committees to satisfy, and the vacuum of space offers a natural way to reject heat, coupled with unlimited energy from the sun. Let's turn now to Sophia Space's unique architectural solution for building orbiting data centers. The vision behind Sophia Space. Sophia Space builds its system around modular units it calls tiles, short for Thermal Integrated LEO Edge. Each tile is self-sufficient in terms of compute, power, and cooling. It generates its own power from solar cells on the sun-facing side, handling its own compute, and radiates heat directly into space from the opposite side. Because power and cooling are handled locally, scaling the system is mainly a matter of adding more tiles. Data moves between tiles using fiber optic links. Only data is shared, not power or cooling fluid. Putting all the essential functions onto a single tile simplifies assembly and removes some of the single points of failure that appear in more centralized designs. Conventional approaches often rely on pumps, fluid loops, or shared heat pipes. If those are damaged by debris or simply fail, large parts of the system can be forced offline to maintain thermal balance. Sophia's distributed design aims to avoid that bottleneck. The company believes this architecture can eventually scale to around 100 megawatts and deliver performance similar to terrestrial data centers, but without the land, water, and local environmental constraints that limit ground-based facilities. In the current design, the tiles are small modular units, roughly 4-inch squares in some descriptions, each carrying multiple processors. They draw power from the solar cells on the sunlit side and reject heat into the cold vacuum of space from the dark side. There is no need for a central cooling plant. The company plans to deploy 50-meter squared structures containing thousands of tiles, producing many megawatts of power, providing a powerful AI compute facility in space. In time, the size of the tiles will be miniaturized while providing the same amount of power. Upcoming events. Sophia Space plans to fly its first on-orbit demonstration of the tile modules in 2027. The tiles will be integrated onto an Apex Nova satellite bus. In 2028, the company aims to begin selling tile systems and components. Constellation-scale testing is then planned for 2029 and 2030. Beyond that, Sophia Space envisions full orbital data centers built from roughly 2,500 tiles. What do you think of Sophia Space's architectural approach to orbiting data centers? Are modular tiles the right approach to building large orbiting data centers? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoy space videos and want to support independent coverage of the space sector, you can get early access to every new video on Patreon, along with ad-free viewing. You can also buy me a coffee to help keep the channel going. Links are in the description. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.